We now need to talk about the rather scary concept of dispatch when invoking functions. Now, essentially, the word dispatch basically means how does the compiler figure out what to call? And there are different ways of actually dispatching on an invocation. The two ways which Rust supports are static dispatch and dynamic dispatch. Just as the name suggests, static is something where things are already predetermined, and dynamic is something where things are not predetermined and they can be determined at runtime. So static is by definition more efficient, and let's take a look at the way you would typically implement this. So let's suppose that we want to make a printable trait for our type. So we'll have a trait called printable, and we want to have a method which formats the type that's provided for into a string, for example. So I'll have a function called format, and this function is simply going to require that we return a string of some kind. So now we can take this trait and we can implement this trait for an i32, for example. So I can say impl printable for i32, and here all I have to do is I have to define this method. So that's fun format self, return a string. All we're going to do here is we're going to call the format macro, which acts kind of like the printline macro that we've seen already, meaning that the first argument is the format string, where you can specify what additional arguments need to be dragged into the string, and the other arguments are what actually gets inserted. So here it is, format with an exclamation mark, and here for an i32, I'm going to say this is an i32 and here is its value, and then we provide the value itself by dereferencing the self. We don't need a semicolon here because this is the return statement. This is what we're actually returning. We're returning a string which is the result of this formatting operation. And similarly, we can implement this printable for some other type, for example, for a string. Why not? Let's have it for a string. So I'll have function format, once again, taking self, returning a string. And here what I'm going to do is I'm going to have a similar kind of construct. So I'll format. This time I'll say this is a string. Here is its value. And once again, dereference self like so. Okay, so we have the trait defined for an i32 and for a string. Now, it's very easy to actually start using this trait because essentially let's have a equal to 123. So this is an i32, and let's have b equals hello dot to underscore string. So that's going to get us a string with the text hello, and we're going to basically invoke the method on both of these types. So this is also rather easy and nothing special about this. So I can just print line. I can print line a dot format like so, and I can do the same thing for b. And when we run this, and I hope it builds, we get the output that we would expect. So i32 with a value 123 and a string with a value hello. Okay, now this is very simple, but let's suppose that we are a bit tired of this whole print line thing. We want to have a function which actually prints whatever you feed it. And it's not going to be a macro, it's going to be a fully fledged function, something that you actually invoke. And to do this, what we're going to do is we can define a function in different ways. So one of those ways, and that's what would happen, you know, if we were talking about dynamic dispatch, which we'll talk about later, you could simply define a function called print, which would take z of type reference to a printable, for example. But that's not the only way you can define it. And first of all, we're going to define it such that you have to know at compilation time of what you're feeding into the function. So I'm going to define a function, let's call it printed, for example. And here what I'm going to do is I'm going to say that this function has a generic argument of type t. And t can be anything so long as it's printable. And then the actual argument z is going to be of type t. All right, so essentially in here what we do is we simply use the printline macro. We printline whatever the argument is, and we say z.format. That's it. And now what we can do instead of these calls is we can invoke this function, print it with a, and then print it with b. And when we run this, we get exactly the same result. Now, what does this actually mean? what is it that we've written? Well, essentially, when you compile this, what happens is you get concrete implementations of printed for whatever types you actually requested. And this is something that is called monomorphization, a very complicated word. I think I better paste it in here somewhere so that you get to see what it's all about. So essentially what happens is at compile time, what you're really getting is you're getting a function called printed, where z is actually of type string. And similarly, you're getting a function called printed where z is of type i32. And obviously those functions, they do the correct format calls by figuring out what to call. So it's kind of like a substitution similar to what we have in C++, for example, and other languages. So essentially this approach is called static dispatch. Now, why is it static? Well, the reason is that the decision on which printed to call, because remember we're getting two printed implementations, one for a string and one for an i32, the decision actually happens at compile time. And these calls, this printed A and printed B, they actually get replaced by the calls to those monomorphic functions, to those functions which actually determine the concrete implementations of those types. So this is called static dispatch.